here's an interesting little quiz, I guess, for you. So no matter where you're entering physics, maybe in grade 11, maybe in first elementary kind of college course, or maybe even in university. So typically in physics, in the introductory side, you're going to be asked, or at least you should know and be aware of things like scientific notation, unit conversions, sometimes significant figures, so in terms of measurement, and you should have a little bit of practice on that. And here is a quiz. So there's a few questions here that have been posted. So it looks like there's some unit conversions, okay, right here. There's some little application here, okay, that is provided to you. So let's take a look at these and let's see if you can complete this. Now I'm going to put up a link to this file and you can look in the show notes or in the description. Okay, so I'll put up a link. You can download that particular file if you want to work on this on your own. So let's tackle this kind of question by question. So here's question number 1. So it's asking us convert each measurement to scientific notation. Okay, so we have 2 measurements right in here, so A and B, and we can convert this to scientific notation. So the first one, so 24,500, it looks like it's meters. So if you want to change this to scientific notation, so recall, okay, so you're going to be starting off, so back in where the decimal is, although it's not really provided here, but you're going to be shifting the decimal over so that you will have a mantissa, which is between 1 and 10. If you've forgotten scientific notation, I'll put up a link up above there to the introductory. And once you do this, then you're going to get 2.45. Okay, so those zeros are actually not significant, so we can leave it as it is. So we have 2.45 times 10, and you shifted it over 4 spots. And now don't forget your unit because it is a measurement. So that would be the first one, part A. Part B for you. So this one is 0.00000170 grams. All right, and we want to convert it back. Okay, so now we're going kind of in the reverse direction. So we're going to go 1, 2, 3, 4, and 5. So 1.7. Now I am going to include this 0 because it is after the actual 2 significant digits there that you have. So I'm going to put 1.70 because this would have been significant if it was a measurement. And this is times 10, and this would be to the now negative because you're going in the opposite direction there. So this is negative. And how many do we move? 1, 2, 3, 4, 5, it looks like. And this was grams. So that would have been the actual conversion. And now you have scientific notation numbers. So again, in physics, you might say, well, am I really going to need this? You may not work with this as much, maybe in grade 11 or maybe even in grade 12, but it will come up on and off. And sometimes it's not that you're going to have to do these. You're going to have to try to understand the numbers in scientific notation, right? Like what the meaning is. So the key thing is always remembering, when it's positive exponents and negative exponents and how they relate back to these decimal notations. And again, you can look at that introductory video that I pointed out if you've forgotten about scientific notation. Now, the next question that we have in here is the decimal notation. So we want to convert each one into decimal. So we are starting off with scientific notation. So for this one, let's kind of look at part A over here. So in part A, so it's 3.1 times 10 to the negative 3. Well, then we would take this, okay, we would take our mantissa, which is the leading number, and then the negative just means that we would shift this over to the left, 1, 2, and 3. So that's our decimal spot. So this would have been in decimal notation. So as you can see there, it shifted over 1, 2, 3, right? So it went in that direction, and then we can put our seconds in there, so it looks like it was a time measurement for us. All right, so that's another one right there. The last one, so the last particular example that you have been given, so that's this one, which is the B, and that is 6.92. Now it's times 10 to the 6 kilograms, so we got to go in this direction. So we're multiplying by 6 times. 1, 2, 3, 4, 5, and 6. So these you, of course, are going to be filling in with zeros. So your answer is, there you go, and it is kilograms. All right, so those are your 3 answers that you have in there. So those are the conversions between scientific notation and decimal notation. That's a good deja vu. Sometimes you might see this because when you're studying exponents, you know, depending on your math teachers, you might be exposed to this. But sometimes students are not exposed to this until they do get into sciences. All right, so that's the first, few questions on this introductory quiz. All right, so that's questions 1 and 2. Let's see, what else do they have here? In the above questions, how many significant figures? Okay, so this is a great item or a segue into measurements. All measurements, they're not precise. So, we do use significant figures or significant digits, and we want to know how many are in each measurement. And then it says, what was the estimated digit in each measurement? Okay, so those are 2 concepts which are pretty decent. I'm going to put up a link up above there for you if you've forgotten about significant figures or sig figs or sig digits and the estimated digit. You can look at that there. All right, so well, in the previous question, if we're going to be doing this, so in terms of counting, well, it's actually not that difficult. Okay, so within here, so our first one, so this is this one right here. So how many do we have that are significant? That's 1, 2, and 3. So we have 3 significant figures here. That's 3 sig figs for this one. The estimated digit would have been 5. So the estimated digit, I'll call it ED. Okay, so that's 5. And that's this one. And the reason for that is because these zeros do not count as significant. And again, you would have to know what significant figures are. Okay, and you can look at that video if you've forgotten about that. For your next example, okay, that you have in here, so that's this one right here. All right, so how many significant digits? Well, the zeros to the left of significant digits never really count, so actually none of these will be counting. So we're going to be just counting the rest, which is 1, 2. Now, this 0 at the end does count because you have a number in the measurement. All right, so you would have also 3 sig figs, it looks like here. So this is 3 significant figures, and the estimated digit is always the last significant digit that you have, so that would have been the 0. All right, so you can write in there, so that is the estimated digit for that. For question number 2, so if we want to know significant figures here, when it's in scientific notation, it's actually very easy to count sig figs because in scientific notation, your measurements, the mantissa is all that you count. So basically, you don't count any of these. So you're not going to be counting the times 10. Okay, all you're going to be looking at is these. Okay, so this one, and because it already has a decimal in the number, then it's always going to count. Okay, all the digits within here. So this is 2 sig figs right there, and then the estimated digit is the last one. So that would have been the 1. All right, so that's, let me blow this up. So that's this thing right there. And that's the estimated digit, right? So that's the guess that we have in the measurement. In the second one, so the same thing. You're only looking at your mantissa. You don't really care about this when you're counting significant figures. So this is going to be 1, 2, and 3. So that's 3 sig figs for this one. And what's the estimated one? Well, it's the last one, which is going to be your 2. Okay, so we have answered that first question. Here's the second question, third question. So we're done this one. All right, so now we have a little bit of work ahead of us. It looks like we're going to have unit conversions, and it says round your answers to the same number of significant figures as the original measurement. All right, so that's not a problem, so we can certainly do this. Okay, so for the first one, so part A, 76.2 meters, they want to convert this to millimeters, so this is a prefix conversion. right? So meter and meter, so you have your base right there. So this one, you can just go ahead, and move the decimals around. You're going to be, so if you've forgotten about kind of metric prefixes, again, I can put up a link up above there. You can watch that video to get yourself reacquainted with that. So this one is not very difficult, but also you may or may not know, but 1 meter is equal to 1,000 millimeters. All right, so that's what that equals. But if you're just working with prefixes, okay, so very often, so in terms of prefixes, maybe I'll put this up here. So, you typically will have, kilo, okay, then you have hecto, you have deca, then you have your base, and then you have going to the decimal places. So this would have been deci, centi, milli. Now, of course, these prefixes continue. You can look at the video if you want. So we are starting from meter, and you can shift this over. So that's 1, 2, and 3. So you're going to be shifting this over 3 decimal places, which again, okay, is exactly this. All right, so that's 1, 2, 3. So 76200 millimeters. Or if you want to do the direct unit conversion, so cancel your meter, put it at the bottom. That's 1 meter, and it equals to 1,000 millimeters. So that will cancel, and you're going to get exactly the same thing back. So that's just a metric prefix. For part B, okay, so for your second one right there. So this one, we have 0.35 hours. We want to turn this into seconds. All right. So in terms of seconds, so we are going to take this, multiply. We don't want to have hours. There's 1 hour is equal to 60 minutes. So that will cancel my hour. I am stuck with the minutes, but I want to get rid of the minutes. So I'm going to put the minutes at the bottom right there. So 1 minute equals to 60 seconds, which is what I want. So the minutes are gone. And now this will give you your answer. So let's just take a look and see what this gives us. So 0.35 hours. So well, it's going to be a lot of seconds. Times 60 times 60. So 1260. All right. So 1260 seconds. Now, it does say, so within here, so I can just kind of say, so round, it does tell us to round to the same number, all right, of significant figures as you have. Well, this has only 2 significant figures. This would have 3 significant figures. So if we want to have only 2, like we have over here, then this would have been rounded to this many seconds, okay? So if they do ask you that. Now, rounding with significant figures, again, I can put up a link up above there for you, all right, if you want to see that. Okay, so that is the answer. Now, if they didn't tell us to round, you can just leave it at 1,260 seconds. So that was C in there. Sorry, that was part B. Part C, well, let's take a look at part. Okay, let's take a look at that one. I'm going to actually remove this so I have some space to work with. So for part C, so this is 4.7 and it's kilograms. We want to change it to pounds. They do give us this conversion. So, well, let's get rid of these kilograms. Notice 1 kilogram, 2.2 pounds. So the kilogram is gone. And, we have our answer. So whatever that is, 4.7 times 2.2. So 10.34. 10.34. And that would have been pounds right there. So that's what you have. And now again, so if you want to be able to have 2 significant figures, well, this one's actually going to be a little tricky. Because if you want 2 significant figures, notice that in order to write this, right, and have 2 significant figures, okay, then currently we have 1, 2, and then 3, 4. So we have 4 significant figures. So if we round this and we try to round this to 2, well, the 3 is not going to round this up. So this is going to be 10, right? But writing it as 10 means there's only one sig fig. So, how can you write it in a notation that shows you that it has two significant figures? Just put it in scientific notation. Now, I know this is kind of redundant in here, okay, but if you wanted to, this would have, because this would have two significant figures because of the way that you're putting in the decimal. All right, so there you have it. So that's the answer. So in terms of conversion, not bad. If you are asked to round and keeping sig figs, okay, so then you have to kind of think. Now, sometimes, by the way, if people are writing it like this, they might put a decimal here at the end, which is going to be 10. Or sometimes, you might see that you'll have a little decimal just below it. Okay, so that's also will mean that this 0 actually counts. I typically just like to leave it in scientific notation because it's very obvious how many significant figures this would have in here. All right, okay, so let's continue. So this would have been now D. Now this is 0.85 and it's beats per second. Okay, so beats, I'm gonna write it like this, beats per second. Now they wanted beats per minute. Okay, well then we don't want those seconds. So we got to get rid of the seconds. Now the seconds are in the denominator, so I'll put it in the numerator to cancel, and there's 60 seconds in every minute. And so that second is gone. Now it gives me minute, so it's beats per minute. I guess that's the heart rate, okay, or frequency that we have. This is going to be 0.85 times 60 equals, so that's 51. Oh, well, that's a great heart rate. 51 beats per minute. Okay, so two significant figures. Well, two significant figures right there. 51 is really good. Okay, so someone is exercising or is just really lucky to be able to have a 51. Maybe that's a resting heart rate right at wake up for someone who's probably pretty active. Normally people won't have such a low heart rate. All right, so that is D. Okay, so let's take a look at E for this one. So I'm going to delete this out. Let's move this, delete this out, and now this is going to be for E. So 25, this looks like it's some kind of an area. They do tell us that 1 meter is equal to 3.28, feet. So let's get rid of those feet. That's not what we want. So we're going to put feet at the bottom. And we know that this is 3.28, 1 meter. Now notice it's squared. So I hope that you remember that, because you're squaring it, that means you're going to have to square this or multiply it 2 times. So that squaring is going to now take care of what we need. So let's see what this will give us. So to punch this in is going to be 25 multiplied by, open your brackets. I mean, don't, try to get too fancy here. Close your bracket and then, put the square on your calculation so that you have it in there. And then you can find out what this is. So this is going to be 2 so notice two significant figures right there. This forces you in those sig figs. So that's going to be 2.3. That's what we will have, and this is going to be meters squared. All right. So this is what you have. So notice 25 feet squared is only 2.3 meters squared. Now they're equivalent, right? But meter is obviously a bigger item here. All right, so that is E. Now what about F, which is the last one? Okay, so this one looks complicated. It has a scientific notation in it as well. So 1.8 times 10 to the negative 4. So this is centimeters squared per second. We want meters squared per minute. Okay, so, well, first of all, let's get rid of that centimeter. Now, this is, again, it's a prefix, but I hope that you remember. So, 1 meter is equal to 100 centimeters. Okay, so this one, okay, is one which is very common. So even if you haven't gotten into physics, you probably will know that 1 meter equals to 100 centimeters. So right there, so we're going to put 100 centimeters, that equals to 1 meter. And because of the squared, I'm going to square this right there. So that gets rid of this, right? So that's the centimeter, which is gone, right? It's going to leave us with meters. Maybe let me change the color. And then the next one is, well, I want to get rid of seconds in here, and this looks like they want it per minute. Okay, fine. So, well, so seconds goes on top. There are 60 seconds in 1 minute. Now the bottom, it's not squared or anything, so we just leave it as it is. So this second will cancel this second, and now we have our answer. So this one, now as you're working this out, how can you input this in here into your calculator? So this will just depend on what kind of calculator you have. I'm going to actually put this in brackets. So 1.8, sometimes, it's easier just to say times 10 and then, reach to the exponent. Okay, and this is going to be -4. So I'm going to have that. Okay, so that's just entering this in. You can, of course, depending on your calculator, you can talk to your teachers and see how this can be inputted in. And once you have this, now you can say, okay, so multiplied by, and this is going to be, so again, I'm going to put 1 all over 100. This is all in brackets. This one is squared. And then finally times, I guess, it's just times 60 because it's 60 over 1. So I won't even put it in bracket. So times 60. Oops, I have too many times. All right, so there you go. It already leaves it for us in scientific notation. So that's great because it's very small. So this is -6. Now, for sig figs, okay, notice that this has 2 significant figures. This has 3 significant figures. So you would have to round this if you want the same amount. At least that's what they ask. So that's rounded to 2 sig figs, and then we can put our units, which is meters squared per minute. So there you have it. All right. So those are all the conversions there. So it's a nice little quiz here as we're going along. Number 5, identify from the measurements each physical quantity in the last question, except the last one. Are the measurements scalars or vectors? Okay, so, scalars and vectors. So that's a good introductory item, right? So that's what you have. I mean, I can put up a link above there to scalars and vectors. Typically you might touch on this in another course, maybe like a math one, but you will slowly jump into scalars and vectors in physics as well. So teachers will be probably introducing you and letting you know which measurements are scalars and vectors. And then it says, how do we know? Okay, well, so we have to do 3 things. We have to identify the physical quantity. Is it scalar or vector? And then how do we know? Okay, except the last one, which I guess was a complicated one there. Although it looks like it's a rate, so it looks like area changing over time. But we'll do all the other ones. So for A, well, this one's simple. So this one is just some kind of a distance. We don't know exactly what it is. And it is definitely a scalar because it has no direction, right? There's no east, there's no bearings that they give us, nothing. So we just assume it's actually scalar. And looking at all of these, it looks like all of them are scalars because none of these actually, even the last one, give us a direction for the measurement. So if they do that, that means they're just scalars. All right, so if they do not have a direction. So at least that one is an easier one to answer. So first one, so this one is a distance. Okay, so that's what we have. Second one, well, that's time, right? Now it could be maybe period, right? So the length of one cycle, but there's no more information, so you can just say time is fine. Okay, so that's the quantity. This one, the next one, so kilograms, so that would be a mass. Okay, now pounds, typically we don't say that's a mass. We typically will say that that's a weight, but some people interchange it, right? But since it's kilograms as our measurement, so I'll just say it's mass. Next one, so beats per second. Okay, so anytime, so beats or cycles or rotations per time. Okay, so that is a frequency, right? Now this is a specific frequency because it looks like it's beats, per second. Now I don't know I assumed that it was a heart rate, but I guess it doesn't necessarily have to be. Maybe it's something else. Okay, but it is a frequency. All right. The next one, this one is an area because it's feet squared. Okay, and then the last one, it says to kind of ignore, although it looks like we have an area on top and then we have a time at the bottom. So it's some kind of a rate. So there you have it. So that's question 5. Question 6. Okay, so that's the last one. This one is actually a little word problem. So a patient has been monitored after surgery. All right, from the screen monitor given, approximate the heart rate, which is the frequency, and the period. Okay, well, so this just assumes that you have to know what frequency and periods are, right? But if you've studied time and you know where time comes from, then you should be aware. Now, this one is actually very nice. Now, we are going to be approximating because, we're kind of guessing, right? This is given to us from a monitor that we have in here. Now, notice that the time scale here, so this is time, and it looks like it's in seconds. So they put S there in brackets, right? So this is, I don't know. So this looks like it's 6 seconds, 7 seconds, 8 seconds, 9 seconds, and so on. So, how do we tell what this is? Well, what I would do here is, you have your heart rates, right? One beats, another beat, and so on. So you have all of these beats. But really, we know from this time frame, so from here, and let's guess it all the way up to the end. Don't try to guess one, so I know that this is one particular, cycle, at least that's shown, and then, or one from here to here, because it's a little harder to guess. Take a bigger scope if you can, just to see. So here we know that this is 1, 2, 3 seconds, in between, right? So that's what we have. We know, so this is what I'm going to put in here. So given pieces of information. So my time is equal to 3 seconds, right? So that's the total time that I have. Now, we do have to know how many cycles, right? So how many cycles this is, because frequency is number of cycles per time, right? So that's frequency is equal to number of cycles per time. And then period, well, period is the opposite. So it's the time, divided by the number of cycles, right? Or, it's 1 over frequency. So within here, so counting this up, so it looks like, I'm going to try my best here. So it looks like, the way that it goes, so right here, if I draw this out, this would have been, so as you can see here, so from right there to right there, so this would have been like, so starting from here, going up to here, so that looks like one cycle. This looks like another cycle, because they're the same patterns repeating, right? 3 cycles, and this is 4 cycles. So that's 4 cycles, right there. So I know that it's going to be, so the number of cycles that I have is equal to 4 point, and now, yes, we have to kind of approximate. So this, so from here to here, right? So that's not a full cycle, right? So the way that it is, it looks like, so looks like it's somewhere over here. So this would have been another cycle. This would have been the 5th one. So now you're guessing, what is this fraction in comparison to this whole thing? So I would say, it looks like maybe 1/4 of a cycle, right? So now your guess might be different. That's why they say approximate, but you should be somewhere close. So I'm going to put, 4, maybe in 1/3. I don't know, 1/3. I said 1/4, maybe 1/3. Okay, so let's just put that in here. So that's what I have in there. All right, so in terms of that, so what does that mean? That means my frequency would be, so number of cycles, within this. This is per second. Now, it doesn't really state it here, but I guess it's heart rate, so maybe we might want to change this back to minutes. okay, within here. So this would have been giving us, so notice if we did this, this is 4.3 divided by 3. So this is what we would have gotten, right? So I'm going to just leave it. I'm not going to round it, okay, at all as we're having it yet. I'm going to put this bar because those 3's are repeating. But this is per second. So this is beats, okay? This is beats per second. If you wanted this to be, okay, in beats, so notice beats per minute, then you can do your unit conversion. So you can say 60 seconds is in 1 minute, right, to cancel this off. So that means I would have to take this and multiply it by 60. And that would have been, okay, well, it looks like it's 86. Okay, so 86, no, because notice all the 9's. So I'll just round this off. So this looks like 86 beats per minute, okay, is the frequency. Now, in terms of the period, so don't forget that period is equal to, so whenever you're doing questions with regards to period, so for that, on the period side, it is time, okay, divided by the number of cycles. So you could have said 3 seconds, you know, over 4.3, okay, to get an approximate answer in here. So 3 divided by 4.3. So it is 0. It looks like, you know, 6, 9, 7, 6, etc. If they wanted us to round, you know, maybe I'll round this to about 0.7 of a second. All right. And what this means is that one of your beats, your heartbeats, takes 0.7 seconds, right? So that's what's actually happening. So one cycle, the length of one cycle is 0.7. Now, notice that in here, when you are doing your period, it is the reciprocal. So it's, notice the inverse right here. So it's the reciprocal, okay, of your frequency. So if you know this, you certainly can change it back. Now we also knew this, so we can change this back. Now it was in seconds, and this is in seconds. So notice what would have happened. If we took the original and we said 1 divided by the frequency for, you know, whatever, 3's, okay, notice you're going to get exactly the same thing. And that's your period right there. All right, so there you have it. So it's a nice kind of little question that we had in here, and a nice little quiz in total. All right, so thanks for watching. Okay, hope that you give it a thumbs up and you found this useful. See you in a future video. Bye, everybody.